Welcome to the Introduction to Software Development on SAP HANA. This is the first course in the new Open SAP online e-learning platform. My name is Thomas Young. I'm Director, SAP HANA Product Management, and I specialize in SAP HANA development tools. I'll be your instructor for this course. The course will consist of 6 weeks, plus 1 week for our final exam. In each week, there'll be a number of videos similar to the one that you're watching now. At the end of each video, there will also be self-tests to help you gauge your progress. At the end of each week, we'll have weekly assignments. These assignments are graded, and you'll earn points towards your record of achievement. We also have an online forum. You can go there to collaborate with your fellow students, as well as to ask questions. Finally, you can expect that it will take about a half-day effort to complete each week in this course. Now moving on to week 1, unit 1, we'll begin with some basics about SAP HANA native applications. So first of all, you may be wondering, what is SAP HANA? Well, it's several things. Of course, SAP HANA is a platform. It's offered as both an appliance and it's offered as a cloud offering. And inside this platform is our ability to use both SAP HANA as a database and SAP HANA as an application platform itself. And we're really going to talk about all of these aspects throughout this course. So at its core, SAP HANA is, of course, first and foremost a database, like other databases on the market, but also with capabilities that other databases don't have. So first of all, SAP HANA is an in-memory database. That means that all the operations that happen in memory. It's not just about caching some of the data in memory or performing some of the operations in that cache, but truly everything from all the write operations, all the read operations take place in memory. And because we know that all operations are performed in memory, we can really optimize the software of the database engine, knowing that we're always going to have that fast memory access. The other thing about HANA that is rather unique is that it's built on top of a modern architecture. It's designed for the way that CPUs are processing today, meaning that it's designed for massively parallel processing. And it's done in such a way that you as an application developer don't have to program in a special format. You don't have to understand threading models and sync points. You'll get the benefits of massively parallel processing, spreading your queries across multiple CPUs and even multiple server instances, and it's the database platform that does most of that work for you. And then finally, one of the final unique aspect is the fact that HANA can store data both in a row format and in a column format. Now, most databases store data in a row format, as you see on the left side of this slide, and that means that all the data for a single record is stored together, but it does mean that as you move from column to column, different data types are encountered. This also means that if you want to do a scan, for instance, across all countries, a particular column in your table of data, that you're going to be skipping around looking for that data, and that often leads us to have to build secondary indexes in a traditional database. However, in SAP HANA, we have the ability to also store data in a column store. And this is how most tables are defined in SAP HANA. And when you organize data in a column store, this means all the data for the same column is stored together in memory. So as we see here in this diagram, all the country data is together, all the product data is together, all the sales data is together. This has several benefits. By putting all the same data types together, meaning country, all the data for country has the same data type, the same length, this means that the data will compress much better. And this is partly how we're able to put the entire database in memory, is that we get much better data compression than other databases. The other benefit is that basically every column is a secondary index. So there's no need to build indexes or to materialize indexes and store the data multiple times in different ways, because we're storing everything columnar, we basically have the effect of every column being an index. Now, this all comes together to give us capabilities that we wouldn't have in other databases. It means that we can run queries across huge amounts of data in real time. Because we can leverage both the speed of the fact that the data is stored in memory, the fact that we're designing for multiple CPUs and parallel processing within those CPUs, and that because the data is in memory, the CPU doesn't have to wait for the data to be retrieved from disk. It has direct access to the data in memory. And because we have this high-speed access, we can do things that we wouldn't be able to do with a traditional database, such as apply analytical analysis directly on top of our transactional data without having to copy the data, without having to materialize aggregates and materialize views of the data. We can do those kind of queries and aggregates calculations in real time. And it basically means that with linear processing, by adding more CPUs, we can make any operation run in real time. And then we take these core capabilities of the database and we extend them by saying that HANA is also an application platform. So we introduce into HANA an application server, a programming language, and a dedicated web server as well. So you can really build your complete application end-to-end, from the schema to the database tables, to your data-intensive logic, to your service enablement, even up to your user interface. And that's what we're going to see all throughout this course, is how do you do each of these things? And then how do you put all these pieces together to have a complete new application that's written on top of HANA? Now, when we say SAP HANA native applications, we're really talking about those applications that are built completely to run inside of HANA. And we're able to do that, unlike with a traditional database, because we've built in an application server into HANA itself. This application server is named SAP HANA Extended Application Services, or sometimes you'll see it abbreviated as XS. XS standing for Extended Application Services. Now, the XS name actually has a double meaning. XS also means extra small, meaning that the application server layer is extra small. It is a lightweight application server. And we're able to have this lightweight application server because we're going to push most of our data-intensive processing down into the lowest layers of the database anyway, to leverage the power of all those capabilities that I just spoke about, the massively parallel processing, the in-memory, and the columnar store. And if we do that, if we push most of our calculation logic, most of our data-intensive logic deep down inside the database, then we're left with not that much other processing that needs to take place, because already our presentation logic is taking place on the client device, and that left just a thin layer for control flow logic, service enablement, and maybe a little bit of validation logic. And therefore we decided, well, rather than have to always put another application server on top of HANA to fulfill that small layer, that small need for that control flow logic and other types of logic at that level, let's take the application server and embed it inside of HANA. Therefore, within HANA, we have the ability to have HTTP and HTTPS-based user interfaces. So we have a web server built into HANA. Then we have this application server. That means that your complete application can be deployed to SAP HANA with no need for an additional external application server. And because we didn't just take an off-the-shelf application server and install it on the same physical hardware as HANA, we really engineered an application server designed for the specific needs of HANA, and at a very low level integrated it into HANA. It's another process that runs at the operating system level. And this process that is the application server, this XS, or Extended Application Services, can have inter-process communication to the database process itself. It also understands the HANA native data types. So data can flow back and forth between the application server and the database server in this scenario without having to be transformed into different data types and without necessarily having to move across the network. Therefore, with HANA Extended Application Services, we have an opportunity to build better performing applications than we would with any other application server because of this closeness and this deep integration with the database itself. And really, this gives us the ability to create applications that run on top of HANA that range anything from very small, lightweight web applications. This is usually where people start. They want to create a custom analytic. They want to create a lightweight service, a REST-based service that runs on top of some of their HANA data. But we're not limited to just that. With this HANA Extended Application Services, we can really build all the way up to complex, high-speed, full transactional types of applications. So just showing the breakdown of the layers of an application, we would traditionally think of an application broken down into a couple different parts. You'd have your calculation or your data-intensive logic. You'd have your control flow and your service enablement logic. And then, of course, you have your presentation logic, the building of the user interface and handling user interaction events. Now, within HANA, we want that calculation logic, of course, to be down in the database. We want all that data-intensive logic to be down in the database. And not just in the form of SQL. Throughout this course, we're going to show you other ways that we can rewrite some of our application logic inside the database as well, and really leverage the power of HANA. Now, likewise, the presentation layer, or the presentation logic, we see a shift in the industry that client devices have become more powerful. Whether that's your laptop, or it's your mobile phone, or it's your tablet device, these devices have become so powerful that we no longer have to do the presentation logic on the server side. We can allow the client devices to do both the user interface rendering and the handling of the user interaction events. And this will give a richer user experience because we're not having to go back to the server every time the user interacts with the user interface. Now, this is a trend that we're seeing in the industry as a whole and that SAP is adopting across all of our platforms and technologies, but it comes at a very nice time because we've engineered HANA from the beginning to take advantage of client-side presentation logic. And we will also see this throughout the course as well, how we build these client-side user interfaces, primarily using JavaScript and HTML. And now, as we said, this leaves a thin layer in the middle for your control flow, validation, and service enablement logic. This is the logic that we put in the HANA Extended Application Services. But once again, that is just a subset or another very thin layer that runs inside the HANA appliance itself. It's nothing additional that you have to install, configure, set up, or backup. It is such a tightly integrated part of HANA that we've really blurred the lines between what is a database and what is an application server, and they come together to just make one HANA platform. Now, there's two main types of applications that could leverage SAP HANA. We have the native SAP HANA applications using the architecture that we've described so far, and that will be the focus of this online course. And these applications will leverage a variety of technologies. Of course, we'll have our data-intensive logic written in the database using SQL and SQL script. We'll talk more about those topics throughout this course. We'll also use server-side JavaScript as the main programming language for HANA Extended Application Services applications. And as well, we have support for REST-based OData services with both JSON and Atom XML rendering. We also have built-in support for XMLA and MDX access. So these are the applications that we would consider native because both the database or the data-intensive logic and the application server logic are both executing inside of HANA. The other option that we want to make you aware of is something we call non-native SAP HANA applications. Now, these are the applications that will still leverage the power of HANA. We'll still use the data-intensive logic. We'll still have SQL, SQL script, and other means of pushing business logic down into the database. but they will also use another application server in addition to the one that's embedded inside of HANA. So they'll use ABAP, Java, .NET, and they'll use one of the open standard interfaces like JDBC or ODBC to connect to SAP HANA. In these types of applications, the native SAP HANA applications, we combine everything into the HANA server itself. Therefore, it's really well suited to new applications that you're building from scratch or major additions to existing applications. Because often you have to architect the application from the beginning to leverage this type of architecture. But when you do design for native HANA applications, that we see a real simplicity, particularly for the customers that are installing the applications. They don't need to set up multiple servers. They don't have to set up connections between the servers, multiple sets of user management. Everything can be installed directly inside of HANA. We also see a simplicity at design time for you, the developer, meaning you'll work in one development tool. You'll code both your data-intensive logic, your presentation logic, and your imperative service enablement logic all in one tool. All the development artifacts will be stored together, one set of version management, one set of lifecycle management for all the development artifacts. And that really simplifies the developer's job. This also lends to speed of development. If I can develop my database artifacts and immediately service enable them from inside the same system, and then test without having to deploy, without having to connect two systems together, I can do more iterative development. I can be testing my application development as soon as I'm done coding with it. And then finally, this means that we have one integrated technology stack, which also reduces the cost of ownership for our customers, meaning that they can have one appliance, comes pre-configured from SAP and our hardware partners. It's ready to run and ready to install applications on top of. No additional configuration needed. On the other hand, we have the scenario of non-native SAP HANA applications. And these are the ones that leverage an existing other application server, like the ABAP application server, Java, PHP, .NET. Now, this approach is well suited when you have an existing application that you either want to port to SAP HANA, change it from some other database platform to SAP HANA, or you want to extend it to also run on HANA. So in these environments, you maybe want some level of database abstraction and database independence, but yet you still want to leverage the power of HANA. And you'll use these open interfaces like JDBC and ODBC. In the ABAP environment, we've heavily optimized the ABAP kernel and the ABAP language to also be able to connect to and consume HANA content very, very effectively, very efficiently. But this also allows us to reuse third-party software, such as in the .NET and the Java environment, as well as fairly easily take existing applications and port them to run on top of HANA. Now, as I said, the non-native SAP HANA applications is not the focus of this course. This course will focus on the native HANA applications, but many of the concepts that we will talk about, such as designing in the database, building tables and schemas, writing SQL script, these are all things that are applicable to both native and non-native application development. And then finally, what you can look ahead to learning about throughout the rest of this course is we're really going to go end to end. We're going to start with an empty HANA system and show you how you can set up the development environment, how you do the basics of data modeling and analytics. So we'll start with a completely empty system, show you how to create your schemas, your tables, and then the views on top of those tables. We'll learn about SQL script. That is the SAP's language for creating stored procedures and allowing you to put more and more of your logic deeply down inside the database. We'll also learn how we can both expose and consume SAP HANA data via HTTP, leverage that built-in web server to serve out our user interface. We'll also learn how to code service enablement and validation logic on the server side using JavaScript, and how to use the built-in OData service generation framework. We'll learn about SAP's UI library for building HTML5-based applications, something that we call SAP UI5. We'll learn about the complete end-to-end lifecycle management of how you build artifacts, how you translate them, how you package them for delivery either to through your own system landscape, up from development to QA to production, or if you're a partner, how you can deliver your applications to your customers. And then finally, we'll look at SAP UI integration services. And this is a special offering for building a lightweight portal that runs on top of HANA. So it extends the user interface building capabilities, but going beyond just coding with individual UI elements, but allowing us to assemble widgets together in an overall shell and more quickly build up a navigation frame. So hopefully you see how we'll go from almost nothing in our database, building up our data-intensive logic in our data model, our service enablement, and our user interface. And I hope that you'll join us for the rest of the units and weeks in this course.